Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group. I will teach you Power System 3.
In the previous video, I have discussed about generation cost curve, including input-output curve and heat rate curve. I have also discussed about input fuel cost, total heat rate. Now in this video, I solve a problem related to the input fuel cost, input fuel rate and heat rate, and also related to the incremental cost. So let's start. The heat rate of a 100 megawatt fuel fired generator is 10 mega kilocalorie per megawatt hour at 25% rating, 9 mega kilocalorie per megawatt hour at 40% rating, 10 mega kilocalorie per megawatt hour at 100% of rating, and the cost of the fuel is rupees 2 per mega kilocalorie. First, find the total cost. Second, the fuel input rate, that is heat rate, and also find the fuel cost when the loading is 25%, 50% and 100%. Third, we have to find out the incremental cost in rupees per megawatt hour, and last the approximate cost and the cost using the quadratic approximation in rupees per hour to deliver 101 megawatt. So let's start.
Now at first write down the expression for heat rate. HI equals to AI by PGI plus BI dash plus CI dash into PGI. Unit is mega kilocalorie per megawatt hour. Now it is given that when the generator is 25% of rating, the heat rate is 10 mega kilocalorie per megawatt hour. So we can write AI dash by 25 plus BI dash plus CI dash into PGI equals to 10. It is also given when the rating is 40%. When the rating is 40%, the heat rate is 9. And when the rating is 100%, the heat rate is 8. So by solving these equations, we get the value of A dash equals to 1000 by 9 equals to 111.11. B dash equals to 40 by 9 or 4.44, and C dash equals to 2 by 45, that means 0.0444. So put the value of ABC and we get the value of A dash is 111 by 11 by PGI or PG plus B dash is 4.44 plus C dash is 0.0444 into PG. Now multiplying by PG, we get the fuel input rate. Now as we already discussed about, by multiplying the heat rate by Pg, we get the input fuel. So FPGI is equals to FPGI FPGI or FPG. This is for a particular unit. FPG is equals to PG into H, which is a function of PG. Now this is equals to 111.11 because PG and PG are cancel out, plus 4.44 into PG plus 0.0444 into PG square. Now, what is the value of total fuel cost, CPG? It is given that fuel cost per mega kilocalorie is rupees 2. So we multiply FPG, we multiply the input fuel by 2. So 2 into 111.11 plus 4.44 Pg plus 0.0444 Pg square. So this is equal to 222.22 plus 8.88 Pg plus 0.0888 Pg square. So this is the value of heat rate, this is the value of input fuel, and this is the value of total fuel cost. Now at 25% rating, now at 25% rating, if we put at 25% rating, so value of PG is, value of PG is 25, and we get FPG is equal to, by putting the value of PG 25, we get the value of input fuel is 250 mega kilocalorie per hour, and total fuel cost, that is by putting the PG, by putting the value of PG, or you can just multiply this input fuel by 2, because the cost of fuel is rupees 2 per mega kilocalorie. So C, total fuel cost is equal to 2 into 250, that is 500 rupees per hour. Now similarly, for at 40% rating, F40 is equal to 360 m kilocalorie per hour, and C at 40% is 720 rupees per hour. Now at 100% rating, F100 is equals to 1000 m mega kilocalorie per hour, or, and the cost of fuel is 2000 rupees per hour. Okay. Next, we find out the value of incremental cost. the incremental cost IC equals to DC by DPG, that is equals to 8.889 plus 0.1778 Pg, because the value of C is equal to 222.22 plus 8.889 Pg plus 0.0088 Pg square. Now 0.0889 Pg square. Now we derive it with respect to Pg, so we get this expression, and by putting the value of Pg 100, we get the value is 26.6. By putting the value of Pg, that is 100, we get the value 26.667 rupees per megawatt hour. Now, approximate cost at 101 megawatt, C100 plus delta C, which is equal to C100 plus DC by DPG into DPG. Now C100 is 2000. We have determined this value. And what is the value of DC by DPGI? That is 26.667. And what is the value of PG? PG is 1, because 101 minus 100 is equals to 1. So from this, the value of cost is 2026.75 rupees per hour at 101 megawatt. Now this is the approximate cost. Now by using the quadratic approximation, C101, C at 101 is given by into put the value of Pg, and this is equal to 2.26.75. So in case of approximate cost, it was 2026.67 rupees per hour, and by using quadratic approximation, the fuel cost at 101 megawatt is 2026.75 rupees per hour. The cost calculated approximately is very close to cost calculated by using quadratic approximation. So now I have solved just one problem. Now please solve this type of problem, and especially the problems comes in previous year questions of MACOUT. And if you have any problem in solving those maths, please contact with me. Noted that the heat rate HI equals to PGI AI dash by PGI plus BI dash
plus CI PGI. The value of CI dash is negligible, so this heat rate is now approximated by AI dash by PGI plus BI dash. So for this equation, the heat rate curve is rectangular hyperbola. Now this y-axis is heat rate, HIPGI, unit is megakilocalorie per megawatt hour, and x-axis is output power, PGI in megawatt. Now this portion is BI dash and this portion is AI dash by PGI. So the heat rate curve which gives a linear this heat rate curve gives a linear input output curve. That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.